and the title is A Topic of Interest. The learning objectives is to define interest and understand related terminology, to develop simple interest formulas, and to use simple interest formulas to analyze financial issues. Okay, now we're going to go over here to the next page, page 206. It says interest is a fee paid for the use of money. For example, if you borrow money from a bank to buy a car, you must not only pay back the amount of money that you borrowed, but also an additional amount called the interest for the use of the bank's money. On the other hand, if you deposit money in a savings account, the bank will pay you interest for saving money, since it will be using your money to provide loans, mortgages, etc., to people who are borrowing money. The stated rate of interest is generally given as a yearly percentage of the amount borrowed or deposited. There are two kinds of interest. Simple interest is paid strictly as a percentage of the original amount of money. Compound interest is a percentage of an original amount as well as a percentage of the new amount, including previously calculated interest. We will study simple interest in this lesson and compound interest in the next. Okay, number one, let's say that you get a $600 tax refund and you wisely decide to put it into a long-term investment that pays 5% in simple interest each year. How much money would that add to the account each year? Remember, with simple interest, a certain percentage of an original amount is added to the account. Okay, so when we look here, we're told we had $600 that we put in, and it was at 5% interest. We changed 5% to a decimal. So we would take 600 times 0.05, which would give us $30 each year. Now, number two, it says write out the multiplication you did to get your answer to question one. The next goal is to write a general formula for computing the amount of interest earned. Substitute the letter P for the original amount invested, $600, and the letter R for the percentage you multiply by, written in decimal form, of course. So, if we take what we originally had, the 600 times 0.05, and we would set it equal to the $30. Now they told us to substitute in P for the $600, and then we would substitute in R for the interest rate. And then we know we have equals here, and this $30 is actually, even though it doesn't tell you, is I for interest. And if okay, now I was just asked a question that I said that once we cover 3.1 and 3.2, that's all we're covering this week aside from the exam. And also project 2 is due this week as well. Now remember, your midterm exam is due this Friday. And your project 2, I believe I have it due this coming Sunday. And then also your check assignments are due this Wednesday by noon. All right. Now, what I'm going to do below these letters, and you don't have to do this with every problem, just with this initially. This P stands for principal. This R, I'm going to just draw an arrow. This R stands for the rate, and then we could put interest rate. And then we know the equal is the equal, and the I stands for interest. Okay, now we move on to the next page. It says fill in the following table. which shows the growth of the account over several years, as well as the total amount of interest earned. You'll need a correct answer to question 1. And remember that this is simple interest, so the interest earned each year is always calculated on the original value of the investment. So they tell us the value of the account, which we know we started off with $600. Now, after 1 year, in our previous problem, we determined after 1 year you would get $30 in interest. So now your account value would be $630. You have the original $600 you had in there plus the $30 in interest. Now the second year, if you don't take all this money out, the second year it will go up another $30. But we're not going to write $30. What we're going to do is write what it would equal to when you add it to the previous 30. So that'll be $60. So the value of the account now would be $660. And then the third year, we would add another $30, be $90. So the account would be $690. The fourth year, you accumulate another $30. That'll be $120, which will give us $720. Then another $30, which would be $150. And that will give us $750. Now, if you look here, it says after 10 years. So we would take 30 times 10, which would give us $300. And we'll add it to the original $600. So that'll be $900. Now it says, look carefully at the first and second column of your table. What is the relationship between the number of years that have passed and the total interest earned? Okay. The total interest earned is the interest from the first year times the number of years. But that's how I was able to get the 10th year. That gave us that it was 30 years. Okay, class, sorry about that. We had some technical difficulties. But what I was saying before was, based upon this definition that I gave here, that the total interest earned is the interest from the first year times the number of years. The interest from the first year is 30. When we got down here to the 10th year, we took 30 times 10, and that gave us the total interest, which is $300. So that's how you could calculate the simple interest when you get that first year of interest. Now we come down here to the bottom. We have some definitions. It says in order to compute simple interest, we need exactly 3 pieces of information: the principal, the rate, and the time. The box below describes the terminology we'll use, as well as the letters we'll use to represent the key data. Interest I is a fee charged for the use of money. Principal P is the amount of money borrowed or placed into a savings account. The rate R is the percent of the principal paid for having money loaned or earned for investing money, unless indicated otherwise. Rates are given as a percent for a term of 1 year. The time, or term is the length of time that the money is being borrowed or invested. When the rate is given as a percent per year, time has to be written in years. And then future value is the letter A. This is the amount of the loan or investment plus the interest paid or earned. Okay, so now we move on to page 208, because we're going to put some of this into practice. It says, in the work we did in the group portion, the principal was P equals $600. The rate was 5% written as a decimal, which is R equals 0.05. The amount of time varied when filling out the table of interest and future value. It says here in question 2, you should have discovered that the formula for computing the interest in 1 year is P times R. Use this in your answer to question 4 to write a formula for finding the amount of interest I that accumulates in T years. So we have interest is equal to the principal times the rate, and then we're going to do times time, because that's basically what we did. We did it times time as well. So the formula is interest is equal to principal times rate times time. Number 2, the total value of the account after T years, which we're calling future value and represent with the letter A, is calculated by adding the total amount of interest to the principal amount. Use your answer to question 1 above to write a formula for future value in terms of P, R, and T. Okay, now you have the principal plus the interest. That's basically what future value is. It's the principal plus the interest. Because remember, if you put your money in an account, you would expect to earn interest. And when you earn interest, you expect that interest to be added to the original amount that you invested. So that is why your future value is the principal plus the interest. And it could be written another way as well. This would be principal plus principal times rate times time. Because remember, isn't interest principal times rate times time? So this formula also works. And then finally, you could do this formula one more time, but written like this as well. So either of these will work for future value. Now, it says use the formula from question 2 to find the future value of your original $600 investment at 5% interest in 30 years. Okay. So we will have A is equal to, now I would say this, typically you will encounter this one more than the rest. So let's start off using this form of the future value. So the principal is $600. So it'll be 1 plus the rate is 0.05 and the time is 30 years. Now, when we put this in our calculator, we have 600. We can do the parenthesis. Then we will have 1 plus 0.05, close that parenthesis, open up the parenthesis for 30 years, close that parenthesis and close it again. So your future value is $1,500. Any questions? All right, number 4. It says the right side of your answer to question 2 should be a sum, meaning that it has 2 terms. Use some algebra to rewrite the formula so that it has just 1 term. The result should look like the principal amount times some quantity. Okay, listen. What they were talking about is, originally, this is the formula. A equals P plus PRT, or P plus I. This has 2 terms. They want you to write it in 1 term. So you have P times 1 plus R times T, which is basically what we used up here. Now, just to give you an understanding of what is meant by terms. Terms are only separated by addition or subtraction. This right here, because we're not looking in this parenthesis, this right here is just multiplication. So that's why it's only 1 term. All right. So now we move on here to page 209. We look here in this tan box. It says formulas for computing simple interest and future value. We already went over that. So number 5, it says here, to meet payroll during a down period, United Ceramics Incorporated needed to borrow $2,000 at 4% simple interest for 3 months. Without doing any calculations, make an educated guess as to how much interest you think would be due. Okay, listen. It's 4%, 3 months. Okay. Now, if we look at this, 3 months is about a fourth of, is a fourth of a year, because it's 12 months in a year. 3 months, that's a fourth of the year. So basically, what I would think is, because it tells us here, without doing any calculations, make an educated guess. So this is 1/4 of the year. I would think we would pay 1/4 of the interest. So 1/4 of 4% is just 1%. So I would think that it would be approximately about $20, because that's about what 1% is in this problem. Okay, now for number 6, it says now use formulas to find the interest they paid and the future value at the end of 3 months. Hint, how many years does 3 months correspond to? Okay, so first, we have interest is equal to principal times rate times time. Okay, so the interest is equal to, the principal is $2,000, the rate is 4%, and then the time. Now remember, time is typically calculated in years, and since we know 3 months is a fourth of a year, we'll multiply this by 1/4. Or you could have did 3/12, which is still 1/4. Now, when we put this in our calculator, we have 2,000, and then parentheses 0.04, and then 1/4, and that gave us $20. So your interest would be $20. Now they first wanted us to find out how much interest was paid. $20 was paid. $20 interest paid. All right. So now they want us to find the future value. So we have A is equal to, and we will have to take the principal times 1 plus RT. The principal is $2,000. The rate is 0.04, and the time is still 1/4. Now, we could actually take this here, put a parenthesis and put 1 plus. And if you notice here, yeah, we got that. You notice here our answer is $2,020. Now, let me explain to you why it's $2,020. Because you paying $20 in interest, which means that you still have to pay back the original amount you had plus $20. And this did it all together. Okay, next, number 7. It says, it's very common for simple interest loans to be paid off in monthly installments. This is how many loans for things like furniture and electronics work. Let's look at finding the monthly payment for a simple interest loan. A biotech startup borrowed $68,000 to buy lab equipment at 9% simple interest for 1.5 years. It says find the future value of the loan. Okay, so we had A is equal to principal times 1 plus R times T. The principal was $68,000. The rate is, it looks like, what was that, 9%. And then the time says here 1.5 years, so we could put 1.5. We can put all this in our calculator. 68,000, parenthesis, 1 plus, parenthesis, 0.09, close the parenthesis, open the parenthesis, 1.5. All right. So the future value would be $77,180. Yeah, that's a nice amount of money there. Now we come here to the top of the next page. It says divide the future value by the number of months to find the monthly payment. Now, the future value is $77,180. Now, we got to look at this in terms of 1.5 years converted to months. Now, we know it's 12 months in a year. So it's 6 months and half of a year. So 12 and 6 is 18. So you divide this by 18 months. So when you divide this out, it'll give you $4,287.78 per month. Now we go down here to the bottom. It says here, the problem. Phillips Health and Beauty Spa is replacing one of its workstations. The interest on a loan secured by the spa was $93.50. The money was borrowed at 5.5% simple interest for 2 years. What was the amount that they borrowed? Number 1, what information is provided in the problem? Write out each piece of information as an equation. For example, if the loan had been taken out for 8 years, you will write T equals 8. So now, let's look at the information that's given. First of all, they tell us that the interest is $93.50. So we know what the interest is. They tell us the rate, 5.5%, so it's 0.055. And the time, it says 2 years. Now what we're missing here is the principal. So that's what we're solving for. So it says, what is it you're being asked to find? We are asked to find the principal. Okay, so now we were asked to find the principal. So it says use the simple interest formula to set up and solve an equation to solve the problem. So the simple interest formula is interest equal to principal times rate times time. The interest on the previous page we said was $93.50. The principal we don't know, but the rate is 0.055 and the time is 2 years. So we'll bring down the $93.50. The 0.055 times 2 will give this to be principal times 0.11. Now we could take this 93.50, 0.11p, divide each side by 0.11, and that would give us the principal would equal to $850. Now, of course, we could have put this in our Desmos calculator. So it'll be 93.50 divided by 0.11, which is still would give us $850. Now we come down here to problem number 4. It says after receiving an inheritance, a newly married couple invested $15,250 for 10 years and received $9,150 in simple interest. What was the rate that the investment paid? Use the framework from questions 1 through 3 and show all of your work. Write your answer in the form of a sentence. Okay, so we're given a principal. The principal was the $15,250 that was invested. We don't know what the rate is, but the time is 10 years. And the interest was $9,150. So now we will go through, substitute, and solve. The interest is $9,150. The principal is $15,250. Then we don't know what the rate is, but the time is 10. So we have 9,150 is equal to 152,500 times R. We divide each side by 152,500. When you put this in your calculator to give us 0.06 is equal to R. So we would say the investment paid 6%. That's what it came down to. The investment paid 6%.
I didn't see. Where did the 10 go into?
Okay, since this is all, where did the 10 come from? Or where did it go on the next line?
What?
You was asking where did it go?
Yeah.
Okay, if you take 15,250 times 10, that's where we get the 152,500.
Okay, I guess I just didn't see the extra zero.
Oh, okay. Any other questions? Okay. Number 5. If that couple had been able to find an investment that paid 9% interest, how much more quickly would they have made that $9,150 in simple interest? Use the framework from questions 1 through 3 and show all your work. So we can do the same formula. Interest is equal to principal times rate times time. Now our interest would still be that $9,150. Our principal still will be $15,250. Our rate now is 0.09. But this time we're trying to find the time because we don't know how long we had it in there. So we have our formula. I is 9,150. The principal is 15,250. The rate is 0.09. And the time is T. So we have 9,150 is equal to, so we'll take this 15,250 times 0.09, which gives us $1,372.50 times T. Now, well, just to make sure, let's go on and do that. You have 15,250 times 0.09. That's exactly what we have here. And we divide each side by 1,372.50. That's to get T by itself. So now we could put this in our calculator. 9,150 divided by 1,372.50. So if you look here, we got 6.09 And a lot of sixes here, repeating sixes. So we could round this to say that it takes 6.67 years that would equal to T. Now they ask us how much sooner would they earn the money. Now remember, it took 10 years when the interest is 6%. So at 9 years, well, no, actually, no, not 9 years. In 6.67 years at 9%, we earn the same amount of interest that 10 years at 6% earns. It took us 3.33 years It took us 3.3 years shorter to earn this interest at 9%. Because remember, it was 10 years for the 6%. At 6.67 years at 9%, well, at 9%, it took us 6.67 years. So if you take the difference between the two, we got there 3.3 years sooner by going with the 9%. So it's 3.3 years shorter to get there. Okay. So now we move on to the next page. Now, if I'm not mistaken, I do believe this is the last page for 3.1. Okay. Let's go down here. It says, if you look at it a certain way, simple interest in a saving account doesn't seem terribly fair. Remember, interest is a fee charged for using someone's money. So when you put money into a bank account, the bank is essentially paying you to borrow your money because they could use it to increase their business in other areas. So far, so good. But when you keep that money in the account for a long time, things start to go bad. Let's say that you invest $1,000 into a simple interest account at 3% interest per year. Then, according to the simple interest formula, after 1 year, you would have earned I equals 1,000 times 0.03 times 1, or $30. Don't spend it all in one place. In any case, at the end of that first year, you now have $1,030 in your account, not $1,000. Yet when interest is simple, the amount of interest paid per year remains constant over the life of the investment. Why is this bad for you? Let's see. Forget about the original amount and just think of the $1,030 in your account at the end of 1 year, of year one, as a new investment. If you get $30 in interest over the next year, what percentage did you actually get? Show work. Okay. So we'll go here to year one. Now we know we had 1,000 times 3% times 1, which gave us $30. So we know that our future value here was actually $1,030. Okay, so this is how we got the 1,030. Now we're going to go to year two to complete this problem. Year two. We know that the interest is going to be $30. And then the principal right now is $1,030. And then we know the time is 1 year. What we're missing here is the rate. So you have interest is equal to principal times rate times time. The interest is $30. The principal is $1,030. The rate we don't know, and the time is 1 year. So this will give us 30 is equal to 1,030 times R. We divide each side by 1,030. So we will add 30 divided by 1,030. And that would give us approximately 0.029, which is approximately 2.9%. So you're making less interest the longer you leave the money in that account. It says if you'd actually been paid the full 3% on your $1,030 in the second year, how much more interest would you have earned? Again, show work. So we know interest is equal to principal times rate times time. Principal will be 1,030. The rate will be 0.03 times 1. So this here will give you a whopping $30.90. So you earn 90 cents more. I know that doesn't seem like much, but over time and over a lot of people, 90 cents can be quite a bit. Okay, now we're moving on. So that is basically it from this lesson. This is 3.1. Now we need to move on to 3.2, which starts on page 217. Now, just to give you a heads up, we're going to start on page 217, and our lesson actually ends on page 227. So we have 10 pages, and then we will be done with section 3.2. Okay, lesson 3.2, page 217. It says, like a snowball rolling downhill. Learning objectives: to describe how compound interest differ from simple interest, to develop compound interest formula, and to use compound interest formulas to analyze financial issues. Okay, let's look at the next page. It says here on the next page, it tells you to compute the amount of interest earned during the school year if that amount is 5% of both the principal amount of $600 and the $30 in interest that was already earned in the first year. Find the new ending value as well. Show work, please. Okay. So again, we're on page 218. And so we will have the interest is equal to principal times rate times time. The principal is $600. The rate is 5%. And we know it's over a year. So this is where they get the $30 from. All right, now, so our new principal will be this $30 plus this $600. So our new principal will be $630. Now we'll use the same formula, but this time we're going to substitute in for the principal $630. Then the rate is 5% and it's 1 year. So the interest will be $31.50. So we have to add that to the 630. And this will give us our future value. So it's $661.50. Okay, number 2. It says we know from lesson 3.1 that we can compute the amount of interest earned in 1 year using the formula I equals PR. This is using T equals 1 in the interest formula, I equals PRT. Use the formula with P equals $630 to show that you get the same answer you did in question 1. Yes? Someone had a question?
I didn't have a question.
Oh, okay. All right. Okay. So for number 2, we had interest is equal to principal times rate times time. Interest is equal to $630 times 0.05 times 1. So our interest is $31.50, which we actually did already. All right, now we go down here to number 3. It says use your answer from question 1 to fill in the row of the table corresponding to after 1 year. Then repeat your calculations to fill in the remainder of the table. Keep it in mind that in each case, interest should be calculated on the new amount at the beginning of the year. Okay, so now we know it's $30 for the first year. So this would be $630. We calculated the second year here, which would give us, we add $31.50 to this $30. So it'd be $61.50. So it'd be $661.50. Now after 3 years, we need to take the new balance So we'll take that $661.50 and then we will multiply it by that 5%. And then we know times 1 year, we don't have to write the times 1 year. So then that will give us $33. And since we go 2 places behind the decimal place, it'll be $33.08. So we'll add that here, be $94.58. So this would be $694.58. And then after 4 years, same thing, as far as the same procedure. We'll take $694.58 and multiply it by the 5%, so it'll be $34.73, which we will add here. And then that would give us $129.31. And we add that to 600, be $729.31. Now, it says if all went well, you should have found that at the end of 4 years, the count would be $9.30 more when interest is calculated on the new yearly amount rather than the original principal. This type of interest is called compound interest. And each time the new amount is calculated, in this case at the end of each year, we say the interest has been compounded at that time. Since interest is being compounded once per year in this example, we say that it is interest compounded annually. You're probably not overly impressed by the extra 9 blocks, but when we develop some formula for efficiently computing compound interest, we'll be able to see that something very interesting happens in the long run. So let's get to work on developing a formula by looking for a pattern. All right. So we go here, page 219. Now, 219 have a lot of little examples here that we can do, well, that we're going to do. It says it has value after year 1, they're looking for the future value. You have the principal times 1 plus, this is the rate, and it's supposed to be times time as well. So if you look here on after year 2, after year 3, you notice here that you're writing this more than one time as far as the parenthesis is concerned. So just to give you a quick little overview here, we know we're going to need this formula here. A is equal to P times 1 plus R times T. Then we'll worry about exponents later. Now it says value after 2 years, value after 1 year, 1 plus 0.05. Then we have 600 times 1 plus 0.05 times 1 plus 0.05. So it'll be 600 times 1 plus 0.05 squared. Now number 4. Now fill in the boxes in the computation to find the value after 3 years. Value after 3 years, value after 2 years, 1 plus 0.5 equals. Now, the value after 2 years is here. So it'll be 600 times 1 plus 0.05 squared. Now, that's the value after 2 years. So now this is the 3rd year. So with this being the 3rd year, this parenthesis will be taken to the 3rd power. Because remember, you have this to the 2nd power times itself to the 1st power. So you will add the exponents. Okay, now here comes the key observation of this lesson. So fasten your seatbelt. So far, we know the following. Year 1, the basic future value formula. Year 2, the parenthesis is squared. And then year 3, the parenthesis is squared. Or taken to the 3rd power. It says make a conjecture as to the value after 4 years and 5 years. So I would think it still would be 600 times 1 plus 0.05, but this time it'll be to the 4th. Then the next time it will be to the 5th. It says make a conjecture as to the value after t years, where t represents any number of years. Value after t years, so it'll be 600 times 1 plus 0.05. Then you'll take that to the t power. And it shows the formula right below. Okay, now we need to go over to page 220. It says here, use the formula for interest compounded annually to find the future value of the original $600 investment at 5% interest after 10, 20, 30, and 40 years. Then use the simple interest formula from lesson 3.1 to find the future value if the interest is simple. So now they want us to do the compounded annually versus the future value of simple interest. So these are the formulas. So we have A is equal to 600 times 1 plus 0.05 to the t power. This is the future value compounded annually. And then the future value compound simple is A is equal to 600 times 1 plus 0.05 times t. Now we look here, $600, 5% interest. Now what we could do is this here to make it a lot easier for us, so we don't have to sit here and just keep calculating and keep calculating. We could put this in Desmos. When we put this in Desmos, there are a lot of advantages to doing it in Desmos. So let's put down, now instead of using A and T, let's use Y and X. So let's type in y is equal to 600, then parenthesis, 1 plus 0.05, close the parenthesis, and then we will take this to the x power. Okay, now, we got in our first formula here. Now, what we could do is this here, hit this wheel and hit the table. Now, this has been converted to a table. Now, when we put in these values, it would give us the amounts we're looking for. It says here 10 years. So after 10 years, we're around the 2 decimal places. It would be $977.34. Then we could type in 20 years. That'll be $1,591.98. Then 30 years be $2,593.17. Then finally 40 years be $4,223.99. Okay, now that took care of the future value of the compound interest. Now let's do simple interest. If we do y is equal to 600, we'll do our parenthesis, then 1 plus 0.05, and then again we'll use x instead of t. Now we have our formula here, so we will click on the wheel, click on the table, and we'll do the same thing. We'll do 10 years, that'll be $900. We'll do 20 years, that'll be $1,200. 30 years, that'll be $1,500. And then finally 40 years, that'll be $1,800. All right. So now we look here at problem number 8. It says use the table to draw a graph of the future value for both accounts. Then write a verbal description of what you learned from the table and the graph. Make sure you choose an appropriate scale for each axis. And of course, label that scale on your graph. Do something to distinguish the two graphs. Use different colors or make one dashed or thicker. What kind of growth does each account illustrate? Okay, so let's first try, let's look here. It's 10 to 40 years, so we know that our x value in years are basically going to be the same for both. So if I look here, this is going by, let me see, this is 5, 10, 15, 20, 25. So I think we should go by twos. So that would make this 10, 20, 30, 40, 50. If we go by twos. Okay, now down the side here, we have 1, 2, 3, 4, 5. So it's going by fives here. But I'm thinking that if we go by 200s, this will be 1,000. This will be 2,000. This will be 3,000. Then 4,000. Then 5,000. Okay, now I should use the dollar sign too, because this is supposed to be in dollars. All right, so now we have our scale. Now what we want to do is graph. So what I'm going to do, I want to start off with the simple interest because that's what we started off with before. So with the simple interest, we have 10 and we'll go to 900, which would be about here. And then we will go 20 to 1,200, which would be here. Then we'll go 30 to 1,500. And then 40 to 1,800. Now, we put in 0 Basically, we won't make any interest, but at our 0 year, we will start off at 600 because that's how much we put in. So we connect these points. They basically form a linear, well, a line. Okay, now we go here to the second, which is the compounded annually. So at 0, it's still 600. At 10 years, it's $977.34. So it's a little closer to 1,000. Okay, then 20 years, it'll be $1,591. So it'll be almost $1,600. 30 years, it'll be $2,593, almost $2,600. And then 40 years, it'll be a little bit over 4,200. So we connect these points. It looks more like an exponential regression or exponential growth. So we could put down here that the simple is linear growth and the compound is equal to exponential growth. Okay, now we move on to page 221. So it says here, so let's say that interest is being compounded 4 times per year or quarterly. Going back to our investment of $600 at 5% interest, the banker would not add 5% to the amount to the account 4 times per year. This would correspond to a far higher rate than the 5% they promised. Instead, they divide that rate up by 4 and pay 1.25% every 3 months. The first calculation after 3 months would look like this. So, after 6 months, write a calculation that describes the future value using the same idea from the group portion of the lesson. Remember that interest is being calculated 4 times a year. All right, so we have A is equal to 600 times 1 plus 0.05 over 4, and we will square it. Now, the reason why we would square it is this here. Remember, a fourth of a year is 3 months, which is what we're dividing by 4 with. So then another fourth of a year would be another 3 months, which would give us a half of a year. So that's why we would square this value here. Now it says here, by the time the first year is up, the interest would have been calculated 4 times. So the total exponent on the parentheses in our future value calculation would be 4, which is the number of times per year that interest has been compounded times the number of years that have passed. So number 3, if interest is compounded monthly, after 5 years, it will be compounded 60 times. Because remember, it's 12 months in a year times 5 years would be 60. So if it's monthly, it'll be compounded 60 times. If interest is compounded n times per year, after t years, it will be compounded n times t times. N times t times. Now we move on to the next page. It says, now adapt your answer from question 1 into a formula for calculating the future value of that $600 investment at 5% interest if interest is compounded n times per year for t years. Remember that the interest rate needs to be divided into n equal portions. So it'll be A is equal to 600 times 1 plus 0.05 all over n to the nt power. It says, and that, friends, is how you develop a formula for interest compounded a certain number of times per year. Nicely done. Now, if you look here, we're given the same formula here. And you know, A is the future value, P is the principal, R is the rate, T is the time in years, and then N is the number of times that interest is compounded per year. Now, for number 6. Use the compound interest formula to calculate the future value of our $600 invested at 5% interest compounded quarterly for 10 years. Then compare it to the future value calculated in question 6 of the group portion. Okay, so we had A is equal to P times 1 plus R over N to the NT. Now, we already told that our principal is $600 because that's our initial investment. Our rate is 5%. And then we look at how many times the interest is compounded. Okay, it says quarterly. So that means it's compounded 4 times a year. And then our N value is the number of times the interest is compounded per year. That'll be 4. And then our T value is the number of years, which would be 10. So this would be A is equal to 600 times 1 plus 0.05 over 4 to the 40th power. Now our future value, we can put this right in this calculator. So we will have 600 times 1 plus 0.05 divided by 4. Close our parenthesis, and we will take that to the 40th power. And that will give us $986.17. Because remember, we rounded 2 decimal places with our money. Okay, it says which results in more interest. Now remember, annually, and we did that, let's see, what page was that on that we did the annually? Let's go back here. Here. When we look here at this table, we did future value compounded annually at the 977.34 on page 220. And that's for 10 years, which is what we used here. So, they say by how much? Oh, it just asks us which results in more interest. Quarterly compounding results in more interest. So it results in more interest. And if you need to know how much more interest, it is about $8.83 more. So all you would do is just do some subtraction. So it's about $8.83 more. It's not enough to, buy more than what? You couldn't buy 2 hot and readies with that, but hey, buck is a buck. All right, so we come here to number 7 at the top of page 223. It says repeat question 6, this time using interest compounded monthly, 12 times per year, and interest compounded daily, 365 times per year. In each case, find the amount of interest that was earned, not just the future value. So we will have A is equal to 600 times 1 plus 0.05 over 4 to the nt power. Now in this case, n would be 12 and t would be 10 because this one is compounded monthly and then it's still 10 years. So we'll do a little substitution. So it'll be, what's that, 12 times 10. So when you put this in your calculator, it will give you $988.21. So the interest, because remember, we started off with $600, would be $388.21. That would be the interest. Now, they want us to do compounded daily, which is 365. So we would take this same formula. Oh, you know, I made a little error. This shouldn't be over 4. This should be over n, and it should be over 12, not 4. Okay, so we had A is equal to 600 times 1 plus 0.05 over n to the nt. So we had A is equal to 600 times 1 plus 0.05, and we know our n here is 365, because that's how many times we would compound interest, and t would still be 10. So this would be taken to the power of 365 times 10. Now, when we put this in our calculator, it'll give us $989.20. So our interest would be $389.20. Now it says, draw a general conclusion about what happens to the amount of interest as the number of times compounding yearly goes up. Then, and this question really requires some thoughts, see if you could come up with a reason why this makes perfect sense. A true understanding of the difference between simple and compound interest will really help. Basically, the more times the interest is compounded, the more the future value. This makes sense since every time you earn interest, you will make money off your interest. So when you compound it, every time you make interest, you will make interest on that interest as well. Okay, now we move on to the next page. And on this next page, on page 224, we're actually dealing with effective rate. The effective rate, also known as the annual yield, is a simple interest rate which will yield the same future value over 1 year as a given compound interest rate. The compound interest rate is sometimes known as the nominal rate. And then we have the formula here where E is the effective rate, N is the number of times that interest is compounded per year, and R is the nominal interest rate. Okay, number 9. A loan has a nominal interest rate of 4%, and the interest is compounded weekly. Without doing any calculations, would you expect the effective interest rate to be higher or lower than 4%? Okay, it's compounded weekly. So that means it compounds 52 times. I would expect it to be higher because just like we said, compound interest earns more than simple interest. So the effective rate would be higher. Okay, number 10. It says refer to question 9. Calculate the effective interest rate. So first we'll write out the formula. Now we would substitute. Okay, now first let's write out what these values equal. The rate is 0.04 because it's 4%, and the number of times that interest is accumulated is 52, or compounded is 52. So to be E is equal to 1 plus 0.04 over 52 to the 52nd power minus 1. Now when you put this in your calculator, it'll give you 0.0408, which is 4.08%. Now if you want to see that, let me put in the calculator. Some people need to see that, which is good. So we'll do parenthesis 1 plus 0.04 divided by 52. Oh, wait a minute, I got 50. It's supposed to be 52. All right. And then we would take that to the 52nd power. And then we would have to subtract 1. So if you round this to 4 decimal places, that is where this should actually be approximate. This is where we get the 4.08% from. Okay, number 11. Find the future value after 1 year for an investment of $10,000 at 4% compounded weekly. Now we know compounded weekly, your N would be 52. And then your time, it just told you for 1 year. So let's look at what we have here. We have the principal, which is 10,000. We have the rate, which is 0.04, and we're getting that from the previous problem. The N, we got 52, and the T is equal to 1. So now we would do A is equal to 10,000 times 1 plus 0.04 over 52 to the 52nd times 1 power, which is just 52. And that would give us $10,477.95. Okay. Now, just to be sure here, we know that this is the formula, the principal times 1 plus, and then we will have the rate over N to the NT power. So this is where we derive this these values from this formula. Okay, now we go here to the back. Number 12, it says divide your answer to question 11 by 10,000. What do you notice? So our answer for question 11 is $10,407.95 divided by 10,000, which would be approximately 1.0408. And then it says, what do you notice? If I subtract 1, then I will end up with the same effective rate as in problem 10. Which is 4.08%. Now it says comparing investments is a very important part of any financial strategy. Which savings account is a better investment? 6.2% compounded daily or 6.25% compounded semi-annually? There are different ways you could approach this, so make sure you show all work and explain how you made your decision. Okay, well, I think the easiest way to go with this is probably effective interest rate, because remember, both of these are invested over the same amount of time, which would be 1 year. So whichever one ends up with the higher interest rate, that's the one that is actually the better value to you, or the better investment for your savings account. So we do the effective interest rate, which is 1 plus r over n to the n minus 1. And this right here, we're going to do the 6.2% daily. Now we know the daily, so we'll make that a decimal. R is equal to 0.062. And then the n will be 365, because it'll be daily, it'll be 365. So we had E is equal to 1 plus, the rate is 0.062, all over n, which is 365, to the 365th minus 1. So this will give you approximately 0.06396, which is approximately 6.396%. Okay, now we go over here. Same formula, but this is the 6.25% semi-annually. So our R is 0.0625, our N is 2. So we have E is equal to 1 plus 0.0625 all over 2 to the second power minus 1. Now when you put this in your calculator, it'll give you approximately 0.06348, which would be approximately 6.348%. Now this is higher, the daily, so we could say that the daily compounded interest gives more and is the better investment. Okay, now we move on. We're down to, I believe, if I'm not mistaken, I think these are the last 2 pages. Yes. Okay, interest compounded continuously. It says the goal of the remainder of this lesson is to see if we can figure out what happens to the compound interest formula when the number of times that interest is compounded per year gets really, really large. Large to the point that in essence, interest is being compounded every instant of every day. Wow. As you know, the compound interest formula is A equals P times 1 plus R over N to the NT, where n is the number of times per year that interest is compounded. To rewrite this formula in a form that makes it easier to decide what happens when n gets really big, we're going to introduce a new variable u, which we will define by u equals n over r. First, solve this equation to find a new name for n. Okay, so if we add u equals n over r, they want us to find a new name for n. So what they want us to do is get n by itself. So what we could do is multiply each side by r to get the r out of the denominator. So on one side you have r times u, which would be equal to n, because those r's will simplify out. Okay, so now for 15, it says now replace n in the compound interest formula with the new name for n that you found in question 14, and simplify to show that the formula becomes a equals p times 1 plus 1 over u to the URT. So we'll go with the initial formula. A is equal to p times 1 plus r over n to the nt. Well, we found out that n is equal to ru. So wherever n is, we'll put ru instead. Okay. Now, we have to do a little simplifying because these r's will simplify each other out. So that will leave you 1 over u. And then RUT, now most likely you wouldn't want your exponent to spell rut. Oh, it looked like...
I think you're frozen.
Okay, let me see. What can I do here? Let's see if I could... Let's see if it'll do something here for me. All right. Yeah, it's good now. I don't know, where did I get frozen at?
Yeah, it's good.
Oh, okay. All right. So right now, we simplified out the r's. Now we need the exponent here. Now, typically, you wouldn't want to leave your exponent as rut. So we can manipulate the letters here and put it as URT, because it doesn't matter the order they're in. So we just proved what was in this question here. Now it says, explain why this can be rewritten as A equals P times the bracket 1 plus 1 over U to the U outside of the bracket RT. And that is because of the exponent rule. Power to a power, you multiply. You multiply the powers. So, knowing that, if I did this here, A is equal to P, and I just leave right here, you have this parenthesis taken to the U, and it's all taken to the RT power. So it'd be 1 plus 1 over U to the URT. Because when you take a power to a power, you multiply the powers. Okay, now 17, remember that U is equal to N over R. What happens to this fraction when N gets really big? Remember that R is the interest rate, and it can't change. Since N is the numerator, as it gets really large, so will U. And then we could put down here your answer. As we know, with any fraction, if the numerator gets larger and larger, your final answer is going to get larger and larger as well. Okay, now, I think, well, before I finish this last page here, Some of you emailed me about having a Chromebook. So after this lesson is over, I need to talk to you after class is over. Okay, so now it says here's a summary of what we learned in questions 14 to 17. The compound interest formula can be rewritten in the form below, and as we make the number of times that interest is compounded per year gets larger and larger. The variable u in that expression gets larger and larger as well. So next we'll study what happens to the expression inside the brackets when u gets larger and larger. And we'll find that we can find a much simpler form for this formula. It says using a calculator, fill in the table below. Round to 3 decimal places. What can you conclude about what happens to the value of 1 plus 1 over u to the u power as the number of compounded periods tend to infinity? Tends to infinity is the phrase we use to describe a variable getting larger and larger without bound. Now, if you notice here, they tell us u and they give us values for u, and then they give us the formula here. Now, again, I often say here, we could put this in Desmos and make this a lot easier so we don't have to calculate this all by hand. So what I would suggest is this here. Like, we could make these u's be x's. So when we type this in, we could type this in as y is equal to, parenthesis, 1 plus 1 over x, close that parenthesis, and then we would take it to the x power. And then we will go up here, get this wheel here, and we will hit the table. And then we could put in the values. Okay, 50, what's that? 100, 500, 1,000, 1,500, 2,000, and then finally 2,500. All right, so they told us to round to 3 decimal places. So when we get to 50 here, it'll be 2.692, 100, 2.705, 500, 2.716, 1,000, 2.717, 1,500, 2.717, 2,000, 2.718, and 2,500, 2.718. Now it says here the number that you should have found in question 18 is about 2.718 and is denoted E. Actually, E is irrational. Now listen, on your calculator, whether you're using Desmos or the TI calculator, if you type in the letter E is equal to something. Now in the TI calculator, it would have like, well, let me show it to you, because some of you all are using the TI calculator. All right. So if you did E, you would need to do second and go down to natural log. But see, your E automatically has an exponent. So if you just want to know what E is equal to, you will take it to the first power. And then that will show you what E is equal to. Okay, so now, so what this is saying is this whole formula here is basically equal to E. So now it says, what is the result of the compound interest formula above when the number of times interest is compounded gets larger and larger? In this case, we say that interest is compounded continuously. You could think of this as the interest being compounded every instant of every day. Okay, so if you look at this, the formula is A is equal to P, bracket, parenthesis, 1 plus 1 over U to the U to the RT. So now we don't have a replacement for for P, but if you notice, we do have a replacement for 1 plus 1 over U to the U. Remember, we said that this would equal to E, and then this will be taken to the RT power. So your final formula would be A is equal to P times E to the RT power. So this is your compound continuously formula. And that's what they wanted us to get to here. Okay, now all right, so I guess we do need to do this next page. Let's go here so we can test this formula out, at least at the top. It says use the formula you wrote in question 19 to find the future value after 20 years of a $5,000 account that earns 4% interest compounded continuously. Then compare that to the future value of the same account if interest is compounded annually. So we know compounded continuously is A equals P times E to the RT. So the principal would be 5,000. Then we will have E, the rate would be 4%, which is 0.04. And then T is the time, which would be 20 years. So we can put that in our calculator. So we have 5,000 E to the power of 0.04 times 20. Oh, you know what? I'm going to have to put that in a parenthesis up here. I'm going to do times 20. All right, so times 20. Close that parenthesis. So this would be, the future value would be 11,127.70. Now they want us to do the same account with the interest is compounded annually. So if we do annual interest, remember we would have A is equal to P times, well, I guess I could use this same form, 1 plus R over N to the NT. All right. So we have A is equal to, the principal is 5,000 times 1 plus, the rate is 0.04. It only compounds one time a year because it says annually, and then times 20 years. So we know this is just taken to the 20th power. So we could put that in. So we have 5,000. Then we have our parenthesis, 1 plus, we do 0.04. Then we could take that to the 20th power. So to give us $10,955.62. Now, if we compare these two, basically you earn, let's do a little subtraction, $11,127.70 minus $10,955.62. So basically you earn $172.08 more in the continuous interest. Now 21 we really don't have to do. Basically if you want to do this on your own, that's fine, but we don't necessarily have to do problem 21. Now we are done for today. as far as these problems are concerned for 3.1 and 3.2. Did you all have any questions? Okay, those of you that have the Chromebook, I need you to stay over so I could talk to you about the Chromebook. But everyone else, you are free to go.